Here we're going to look at the probability of outcomes involving two events. Now the events can be either the same or different. For example, if we were selecting a card randomly from a deck of cards or rolling a dice, what is the probability of getting a king from the deck of cards and getting a 6 when we roll the dice? Or we might want to know the probability of getting two tails when two coins are tossed. So let's take a look at a couple of example questions. This is the question we just mentioned. What is the probability of getting two tails when two coins are tossed? It's a good idea to draw up a simple space diagram like this one here, and we can use it to show all the possibilities. So in coin A we can have a head or a tail. In coin B we can have a head or a tail. So in tossing both coins we could get a head and a head. We could get a head and a tail. We could get a tail in coin A and a head in coin B, giving us a tail and a head. Or we could get a tail on both coins, giving us a tail and a tail. So if we look at the question again, what is the probability of getting two tails when two coins are tossed? There are 4 possible outcomes, but there's only one way that we can get two tails. So our answer is a 1 in 4 chance. This next question asks us to work out the probability of getting a tail when we flip a coin and a 6 when we roll a dice. And it's a good idea to start off again with a space diagram. So here's the space diagram with the options for the dice 1 to 6 and the options for the coin heads and tails. And now we'll just fill in our possibilities. So we could have a 1 on the dice and a head on the coin, or a 1 on the dice and a tail on the coin, a 2 and a head, or a 2 and a tail, a 3 and a head, a 3 and a tail, a 4 and a head, a 4 and a tail, a 5 and a head, 5 and a tail, or a 6 and a head, and a 6 and a tail. So that gives us 12 possible outcomes. Now let's go back to the question. What is the probability of getting a tail and rolling a 6? Well, there's only one way that we can get a tail and roll a 6. So that gives us a 1 in 12 probability. This time the question is slightly different. What is the probability of getting a head on a coin and an even number on the dice? Well, if we look at the dice, our even numbers are 2, 4 and 6. And we can get a head on the coin. So we only need to look at our 2 and a head, a 4 and a head, and a 6 and a head. So our probability is 3 out of 12. And if we divide the top and the bottom by 3, that gives us 1 in 4 chance. This next question asks us, what is the probability of getting a total score of 10 when we roll 2 dice? And we'll start off here again with our space diagram. As we're adding in this question, it's a good idea to put a little plus sign up here in the corner so that we know we're adding and not multiplying or something else. And then we simply add the scores that we could get in A to the scores that we could get in dice B. So going across, we could get a 1 and a 1 giving us 2, a 1 and a 2 giving us 3, a 1 and a 3 giving us 4, and 5, 6, 7. Or we could get a 2 and a 1 giving us 3, a 2 and a 2 which is 4, a 2 and a 3 is just 5, a 2 and a 4 which is 6, a 2 and a 5 which is 7, or a 2 and a 6 which is 8. And I'll just continue this on. We could get a 4 and a 5 and a 6 and a 7 and an 8 and a 9, or a 5, 6, 7 8, 9, or a 10. A 5 and 1 would give us a 6, 7, 8, 9, 10, or an 11. And we could get a 7, an 8, a 9, a 10, an 11, or we could get a 6 and a 6, which is a 12. So there are 36 possible scores that we could get, the lowest of which is 2 and the highest of which is 12. The question wants to know what's the probability of getting a total score of 10. So we need to look at all the ways that we can get 10. So we could get a 6 and a 4, for example. We could get a 5 and a 5. Or we could get a 4 and a 6. So there's 3 possibilities of getting a score of 10. So that's 3 out of 36. And again, we always try to simplify. So to divide the bottom and the top by 3 in this case, giving us a probability of 1 in 12. This next question asks us the probability of getting a total score greater than 7. And we can find this from our space diagram. Remember, it's greater than 7, so we can't include 7. We can, however, include all of our 8s, 9s, our 3 10s, the 11s, and our 12 at the end. So if we count these, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 different ways out of a possible 36 outcomes. And again, we can divide by 3 here. 3 into 15 goes 5 times, and 3 into 36 goes 12 times. So there's a 5 in 12 chance of getting a score greater than 7.